Can you see?
Yes, sir.
Okay. See, this is the transportation problem. It is the name itself is transportation, and transportation is what you mean the transportation. See, goods are transported from factory to outlet or factory to shops. This problem is related with that one. And our target is our target means target of the company or target of any businessman or target which involved in the that in the consideration of the problem, that will be, as you know, it will be minimum cost of transportation, definitely, because if cost is minimum, they can give the goods in a lower price, and then people will like. If the transportation cost is higher, then people definitely the cost of the article will be higher, and it will be difficult for the problem to sell it. See how it is started is this, like this. Say for example, a company has 3 factories, one in Delhi, one in Bombay, and one in Kolkata. 3 factories. So suppose if the goods are needed in, say for example, in Bangalore, then which will be preferred? Whether it will go from Mumbai, or it will go from Delhi, or it will go from Kolkata. And definitely Mumbai will be nearer and cost will be less, and then it will be better to give from Mumbai. And suppose the good is the demand is coming from Manipur, then definitely Kolkata will fit it, and that from Mumbai and Delhi that will cost more, and that is why it will be definitely will supply from Kolkata. These are the things which is required here, and why it is so, because transportation cost will be less. And let us see a model of the problem here. Say introduction, or say the introduction is not necessary. Some historical background will be there. I am not giving to it, not necessary also. And let us see transportation table here. This is the origin here, origin, and this is the destination. And origin means you can consider either factor or outlet, a factory or outlet. Say O1, O2, O3 is the origin, and D1, D2, D3, D4, they are the destination. Destination means goods demands are coming from this, and from this O1, O2 supply will go to D1, D2, D3, D4, and this is called, this we will call as transportation table. And then here these are the origins, these are the destinations, and then C11, C12, C13, something is written here. And regarding the X11, X12, it will not in the problem. Say, let us see another problem. These things, the problem is this. This is origin, destination, O1, O2, O3, D1, D2, D3, D4, D5. And these are, see, 2, 11, these are given. These are the C1, C12, C21, C1, C12, C11, C12, C13, C14, C15, like we are writing in the as the elements of a matrix. And this will be C21, C22, C23, like that. And something is also here, and something is also here. Only one value is given, and not two. But here it is written as 2, C11, X11. C11 is what it is given in the problem. X11 is what we have to find out during the calculation. X11, X12 are those we have to find out during the calculation, but these are not necessary. Those within the another box that will be given in the problem. According to that, we have to solve. And here, what is C11 means? C11 is the cost of transportation when goods are transported from O1 to D1. And C12 will be cost of transportation when goods are transported from O1 to D2. Likewise, C13 also cost of transportation when goods are transported from O1 to D3. Likewise, C14 also, C21 also, C22 also, C23 also. C23 is cost of transportation of the goods from O2 to D3. In this way, everything will be here. And then again, A1, A2, A3 is there. B1, B2, B3, B4 is there. And these are called supply. And these are called demand. This A1 means whatever be available in O1, that is called A1. It is the supply. And A2 is from O2. A3 is from O3. And B1 is the demand by D1. B2 is the demand by D2. B3 is the demand by D3. B4 is the demand by D4. See, you consider three factory outlets. One is O1, one is O2, one is O3. And these are the sales depot or sales shop. D1 is one of the shop 1, D2 is shop 2, D3 is shop 3, D4 is shop 4. And O1 has A1 number of items, and D1 demands number of B1 items. These are numbers. And in that way, problem is given like this, and our target is all the things available in O1, O2, O3, they are to be transported to D1, D2, D3, D4 at the minimum cost. Our target is minimum cost. Minimum cost. And that is why normally the sum of A1, A2, A3, total of A1, A2, A3, and total of B1, B2, B3, B4 must be equal. So whatever be the produced by the factory, that is to be consumed by the shops, that is to be taken by the shops. And that is why sum of A1, A2, A3, A1 plus A2 plus A3 must be equal to B1 plus B2 plus B3 equal to B4. Such type of problem is called balanced transportation problem. Balanced transportation. Total supply equal to total demand. That is called balanced transportation problem. If it is not balanced one, then we cannot solve the problem, and that is why we have to make it balanced first. We have to make it first balanced, and after that we will solve. And those not balanced are called unbalanced transportation problem. For unbalanced transportation problem, first thing is to make it balanced, and after that we have to solve it. And here, if you read the notes, then you will know here we will consider two methods. Some other methods are also there, but I will take up only two. Those are more important. And one is northwest corner rule. That is the first to be considered here, first to be discussed. And second is the Vogel's approximation method. This is the second one. First is very easy one and not so much reliable, and second is more reliable. And then see, see whatever I had to mention, it is written here also. It is mentioned here also. See, OI, origin or source from where transportation is to be done. DJ, destinations where articles are to be transported. CIJ, unit cost of transport. Unit cost means when one article is transported, the cost of that is called unit cost. Whatever given here, it is unit cost. And XIJ is the amount of commodity to be transported from OI to DJ. Regarding XIJ, I will tell you. I will explain you now again. AI, total capacity of production. Total capacity of production. Production or storing of the commodity at OI. And BJ, total amount of demand at DJ. J 1, 2, 3, 4. Here I is 1, 2, 3. These are the things given here. Regarding XIZ, I will tell you, see, for O1, total goods available is A1. Then how much it is to be transported to, how much, say suppose A1 is 10, and how much it is to be transported to D1, that is X11. Suppose 2 is transported to D1, then X11 is 2. And 4 is transported to D2, then X12 will be 4, like that. And this total will be definitely equal to A1. It cannot exit A1. It will come A1, but maybe less than, but not, no, exactly equal to A1, should be. It should be. And in that way, it comes. Now let us come to the algorithm for the northwest corner rule. Northwest corner rule means in this figure, what is the northwest? Northwest is always, it should be top left. Top left is the northwest. Top left. In the figure you see, top left is the northwest. And instead of northwest, it is called top left also. Top left corner rule. Because why it is so is that it is start from the northwest cornermost element, and that is why it is called northwest corner. See, step 1. Let us read together and let us see. Check whether summation AI and summation BJ equal. That means that I had already told you, if it is equal, that is called balanced transportation. If it is not equal, first thing is to make it equal, and after that we will start the calculation. If yes, then go to step 2. If no, make it a balanced transportation problem and go to step 2. If it is not, then we have to make it balanced and then to go to step 2. Step 2, start from the upper left hand. Upper left hand. Upper means what I told you, it is top. Top left, upper left. Okay. North or northwest corner, and assign X11 equal to minimum of A1, B1. See, here this value should be minimum of this A1 and this B1. So suppose this is 2 and this is 5. X11 will be 2 because minimum of 2 and 5 is 2, and that is why X11 you will keep 2 here. In that way, it is to continue. And then after taken out 2, from it is 5, 2 had taken out, 3 is remaining. Then for the next step, it will be considered as 3. Thus, either the capacity of the origin O1 or the demand of the destination D1 would be exhausted. The minimum will be exhausted. Whichever is minimum, either A1 or B1, we have to select the minimum. That minimum will be exhausted. And cost matrix would reduce by 1. Here cost matrix will reduce by 1 means what? See, suppose what I told you, it is 2 and it is 3. Then 2 had taken, then this whole row will be eliminated. Whole row will be removed. And now it will be, what is previously? It is 3 by 4. Now it is removed, then it will be 2 by 4. And if it is removed, then it will become 3 by 3 in that way. And that is why it is said here that then the cost matrix would be replaced by, reduced by 1. That is either m minus 1 by n or m by n minus 1. Either row will be reduced by 1 or column will be reduced by 1 in the given matrix. So considering 2 cases. If A1 greater than B1, the demand of the destination D1 is exhausted and capacity of the origin O1 is reduced by B1, and that is capacity of the origin A1 is now A1 minus B1. Now move to the right and assign X1 to equal to minimum of A1 minus B2 and the A1 minus B1 and the B2. Clearly, this can be continued by moving to the left until the capacity of the origin O1 is exhausted. And again, if A1 less than B1, in this case, it is A1 greater than B1. Now, if it is A1 less than B1, then X11 equal to A1 and capacity of the origin O1 is exhausted. However, demand of D2 is still there, and hence X21 equal to minimum of B1 minus A1 and the A2, and proceed to exhaust either the capacity of O2 or D1. And step 3, if equal, then what will do? Then in that case, we will consider this is tie break. And tie break, in previous cases also, I told you, you have to break the tie arbitrarily. And if it is equal, then capacity of O1 and demand of D1 would be satisfied simultaneously. And dimension of the closed matrix would be reduced by 2, M-1 and N-1. Step 4, clearly either the capacity of, it is not somewhat clear, capacity of, it is clearly either the capacity of O1 or demand of D1 separately or simultaneously would be exhausted, and process is repetitive. And since M and are finite, the rim requirement would be satisfied in finite number of steps. Note that since summation AI and summation BJ, no disparity would rise in satisfying the rim requirement. These are the things. And then after that, let us see to the problem directly here. You will be more clearer by discussing the problem. See, this is the problem. Question is, determine an initial basic feasible solution to the following transportation problem using northwest corner rule. This is the problem, and O1 has four number of items, O2 has 8 number of items, O3 has 9 number of items, D1 has 3 demand, D2 has 3 demand, D3 has 4 demand, D4 has 5 demand, D5 has 6 demand. And now, according to the steps given in the algorithm, let us check what is summation AI. It is sum of 4, 8, and 9, it is 21, and summation BI also 21. They are equal, it is balanced, and we can go to step 2. Step 2 first is, you have to start from here. It is northwest corner element, top leftmost, and from this you have to start, and the cost is 2, then supply is 4, demand is 3. From 3 and the 4, you have to take the minimum is 3, you have to put here 3 item is to be transferred from O1 to D1. For D1, supply is met, this column is not necessary. For O1, one more item is one more good is remaining, and that is to be given to somewhere. And that is why it is written here, step 2, starting from the northwest corner, X11 equal to minimum A1, B1, A1 is 4, B1 is 3, minimum is 3, 3 is assigned here. And then step 2A, here, A1 is 4, B1 is 3, A1 greater than B1. The demand of the destination D1 is exhausted, and capacity of the origin O1 becomes A1 minus B1 equal to 4 minus 3 equal to 1. And now we have to move to the left and assign X11 to equal to minimum A1 minus B1 and the B2. And minimum A1 minus B1 is 1 and B2 is 3, minimum is 1, 1 is to be assigned. See here, one is A1 greater than B1, another is A1 less than B1. In this case, 3 is less, and it is assigned here 3. One more is remaining here. Then it will go in this way. It will go to the right. If it is greater, say suppose it is 6, then 2 will remain. And in that case, it will go down. It will go down. And always it will go like this, horizontally and down, horizontally down, not in this way, up, the up and the left will never go. It will always right and the down, right down, right down, like that. Nothing will be like up, right, up, left. Up, left will never be here. It will be always either horizontal or either downward. And in that case, it is small, it is minimum, and that is why it goes horizontal, right, along right. And if it is minimum, minimum is this, then it will go down like this. And that figure also will come, I will explain there also. And then step 3a had done, not 3b, not 3c. Out of 3a, 3b, 3c, only one will happen. Other two will not happen. And here in this case, a happens, and that is why it is like this. And now the capacity for units of O1 is exhausted, but not the demand of D2, and hence move down and assign x2 to equal to minimum of 8 and the 3 minus 1, it is 2, and so on. It will continue in this way. See, the figure is this here. While calculating for your examination purpose, writing of this step 1, 2, 3 is not necessary. You have to start here directly. See here what is to be done. 4 and 3 minimum, it is 3, 3 is here. This is exhausted and this column will be removed. And now it will be 3, and it will be after taken out from 4, after taken out 3, it will be 1. Instead, here you can write by cutting this, simply cutting, and then 1 you can write also. But if you understood, then no need to write. Then here it is 1 is assigned here. This is what I had already told you, x11, and this is x12, and x13 is not necessary, x21 also not necessary. Regarding the x, according to the demand, we will according to the calculation we will have, those not required will not write, and we will assume that those are all 0. And then again after this, it is exhausted, this row is also removed, and this column already removed, and now it becomes, this becomes exhausted. Okay, and now it comes to here, it is 1 already removed, then 3 reduces to 2. Out of 2 and the 8, we have to select minimum. 2 is minimum, then 2 is assigned here, and next to go, because it is 6, then we have to go in this way. And out of 6 and 4, we have to take the minimum. 4 is minimum, then 4 is assigned here, and again this is also removed, this also removed, and now it is between these two, and this will be 4, 2 and 4 had taken, then it reduces to 2 only. With this 2 and with this 5, we have to take the minimum. We have 2 is assigned here, and now after taken out 2, it becomes 3. 3 and the 9, we have to take the minimum. Minimum is 3 here, and after that it is exhausted, this column is removed, and then now it is 6, this is also 6, 6 balanced, then 6. Then in this way all are assigned, and if it is not balanced one, something remaining will be there, problem will not be completed, and that is why we already told you it should be balanced one, otherwise it cannot do. Okay, then now we have to calculate the total cost of transportation. Cost of transportation we will calculate in this way. 3 article is transported from O1 to D1. Cost is 2. Then it will be 3 into 2, 6. It is given here. It is given here. And for this cost is 11. 1 article is transported from O1 to D2. And then it will be 11 into 1. Plus next 4 into 2. Plus next 7 into 4. Next 2 into 2. Next 8 into 3. Next 12 into 6. Total cost is 153. This is the total cost required to transport all the supply to meet the demands. Okay, this is the thing. And then next, see, Do you have any problem here? Anybody who cannot understand, you can ask me question. Any student, anybody who have any doubt, any problem? Ask me.
Sir, how to balance it?
Uh-huh.
Sir, how to
Okay, okay,
balance
okay.
if
How to
there is,
balance? How to
yes, sir,
balance?
supply demand is not balanced, then how to balance?
Okay, okay. In that case, say suppose like this. Let us consider like this. Say suppose instead of this 9, it is given as 6. You consider. Then 3 is required here. Is not it? 3 is required. Better to. Okay. Let us see in this problem. Say suppose it is like this. Instead of this, say suppose instead of this, say suppose it is 6. Then how many require? Can you see?
Yes, sir.
Oh,
Three,
okay. Then how many required by the supplier? 3
three.
more.
Yes.
Yeah. Then you can do like this. You can put a blank column here. You can put like this. Say suppose it is O4. O4 is there. O4 is there. You have to, and then here all the cost will be 0. This is also 0. This is also 0. This is also 0. And this is also 0. And it will be 3 here. Now, is it balance 1?
Yes, sir.
See, it will have no effect
Yes.
because cost is already 0, 0. Say
Yes.
suppose from O4 demand is 3, and then if you transport something from here, then it is supplied, then cost will be 0, then no effect will be there. In that way, we have to make it balance.
Okay.
And likewise, if it is in the what I have to say suppose if it is required in the column also, the same thing will be done in that way. And this is the way of balancing. Is there any more doubt?
No, sir.
Okay. This is what you have to do. And then let us see Vogel's method. See, northwest corner, it is not reliable because we started from here. It is always to be started from here. We are not justified whether it is minimum or not. We are not justified. Only the thing is that we have to start from here. We will go along the east south direction. That is the thing. The starting is fixed and destination also fixed in this case. That is why it may not be the minimum cost. And that is why Vogel introduced this method, and then it will be more reliable. Then let us see the steps. Check if this. It is nothing but to check whether it is balanced or not. It is balanced or not, that is what. If yes, go to step 2. It is same as that of previous one. And otherwise, make the problem a balanced one and go to step 2. For each row of the cost matrix in a transportation problem table, determine the list of the cost CIJs, and next to the list of the cost, determine the difference between these two costs for each row and display them by the side of the transportation problem table against each row. Go to step 3. Let us see step 3. Complete the difference of each of the column also and increase as has been done in the rows above in step 2. Go to step 4. Step 4. Identify among the rows or columns the row or column in which the largest difference occurs. If tie occurs, break the tie arbitrarily. In this case, regarding the tie, always it will be break arbitrarily. If the greatest difference occurs in the odd row, then determine minimum this, and that is minimum value of Cij's in the odd row, like Cik be the minimum. In that way you have to do, but I will explain it with the calculated one. That will be more clearer to you. And then step 5, it is repetition of those one, and then it will come in that way. And let us see the problem here. See here, what is mentioned in the algorithm, I will explain here. See, in this first row, you see in this first row, cos is 1 is 2. This is 2, 11, 10, 3, 7. You can start either from the row or from the column. Anyone you can start. It is no matter which is which is to be done first. Nothing is not there. You can do either along the row or along the column first. Let us start along the row first. See, 2, 11, 10, 3, 7. What is said? You select the minimum and next minimum. List and the next list. List is 2. Next list is 3. Subtract these 2, it is 1. Right here, 1. This 4 and the 4, 8, 9, there is the given a supply demand like this also. And then for the second row also you do like that. Minimum 1. Next minimum means you cannot select 2. You have to say it is 1. 1, 1 equal, then you have to take that 2. 1, 1, difference is 0. You have to take the difference between the first minimum and second minimum. Equal, if there are 2 values equal minimum values, then select both. As first, 1 is first and 1 is second. And next will be 3 and the 4. This is 3, this is 4. This is the first minimum, this is second minimum, and it is 9. Likewise in column also, first minimum, second minimum, 1. First minimum, second minimum, 5, it is 5. First minimum 4, second minimum 7, difference is 3. First minimum 2, second minimum 3, difference is 1. First minimum 1, second minimum 7, difference is 6. 6 is here. Then, see, this is 1, 5, 3, 1, 6, then 1, 0, 1. 1, 2, 3, 4, 5, 6, 7, 8. Among these 8, you select the maximum. Maximum is this. Is not it? 6. Then 6 is to be assigned. 6 is to be assigned. Assignment should be start in this 6, in this column. And then what is to be done? What is to be done? See, this column you have to select. This column you have to select. Then which row is to be selected, that you have to search. This column you have to select. You have to start here. You have to give this maximum 6 here. You have to select this. And in that column, you have to select the least transportation, minimum transportation. See, 1 is 7, 1 is 1, 1 is 12. 1 is the minimum, and here you try to allocate the maximum allocation. See, here the value is 6 and here the value is 8. Between these two, you have to allocate this 6, because always we have to take the minimum. Minimum is 6. 6 is to be allocated here. This is the first you have to start. See, let us see with steps also. It will be more clearer. The TP is balanced and hence go to step 2. Step 2, first and second differences are there. Oh, see, 7 and 1. Fifth column difference 7 and 1. It should be 6, not 8. You change this as 6, not 8. It is not 8. It is 6. It is by mistake. And then see, step 4, the largest difference 6 occurs in the fifth column, in which the smallest cos is 1. Smallest cos, this is 1. Smallest cos is 1 here. It is 6. And then occurs at 2, 5 cell. 2, 5 cell means second row, fifth column. Since minimum 8 and the 6, 8 is this, and 6 is this. 8 and 6 is 6. We allocate 6 at 2, 5 cell, and cross off this column from the cost matrix. This column had already, assignment had done, everything completed, then this column can be cross off. That is why it is, you should cross off like this. And now it is out of the 6 has already, the demand for D5 had completed, and then supply of O2, 6 is given, 2 is remaining. And the next will be step 5. The cost matrix, now from this, it is reduced to this. After cutting off the fifth column, now it is reduced to this. Okay, yeah, it is reduced to this. The largest difference occurs. Okay, step 5. Okay, now it is reduced to this. This earlier it was 5. Now it is 8. It was changed to 2. And now in this case, again, you have to take the difference again. You have to start and take the difference again. Now, for this row, minimum is 2, second is 3, difference 1. Minimum 1, second 2, difference 1. Minimum 3, second 4, difference 1. For this column, it will be unchanged because no column is no row is removed. And 1, 2, 1, and 4, 9, 5, and 4, 7, 3, and 2, 3, 1. And here again, you see 1, 2, 3, 4, 5, 6, 7. Out of this 7, you see the maximum. Maximum is this. Maximum is this 5. 5 is to be allocated in this column. In this column, and minimum will be, minimum cost is here. It is here 4, and you do the allocation here. In the row it is 2, in the column it is 3. Minimum is 2 is allocated here, then 1 is remaining here. Then what is this row will be removed, and that next table will come here again. So this is the next table. I will not see the other thing. Let us come to this table again. Now we have this. Then again we take the minimum. This 2 and 3, it is 1. 3 and the 4, it is 1. 2 and the 3, 1. 9 and the 11, 2. 4 and the 10, 6. 8 and the 3, 5. Greatest is here. Then you have to allocate in this column. And minimum is 4. 10 and the 4, 4 is minimum. Then you have to allocate here. We can allocate here as it is 4, it is 9. We have allocate here 4. And then what will be? This column will be removed again. Then next it will come in this way. Then this is coming. And again take the difference. 2 and 3, 1. 3 and the 8, 5. And 2 and the 3, 1. 9 and the 11, 2. 3 and the 8, 5. And it is like this. Now maximum is, this is also 5. This is 5. And this is also 5. Tie occurs, back the tie arbitrarily. And then only the thing is that you have to do the allocation 5, 5. The largest difference 5 occurs in fourth column and third row. As tie occurs, we break the tie arbitrarily and select fourth column. See, in this case, what it can do, either you can select this column or you can select this row. You can do any one, but we are selecting this one, this column. And then here minimum is 3. We allocate here 4 because it is 4. It is 5, minimum is 4. We are allocated here 4. But if you select this, minimum is 3, you have to allocate here. Allocate here, how much it will be? 3 and the 5, 3 you have to allocate here. That also you can do. You can check it whether that will, whether answer is different by doing that way. And then after this, oh sorry, no. Select this 4. I think they have done the other. I think here it is done the other. Other means 4. 4 is allocated. Oh, sorry. 4 is allocated here. 4 while allocating the 4, not this. While allocating the 4, this row is removed. If you allocate 3 here, this column is to be removed. And this will be the shorter way. Not this one. Not this one. It is this. Okay. And then now the remaining 5 is to be distributed among these. No selection will be necessary. Then accordingly, it is what? It is already 4. This is 1 is there. It is this 5 can be distributed 3 here, 1 here, 1 here, and then it is coming like this 3, 1, 1, and allocation completed. And then cost is this. It becomes 68 only. See, in the same problem, previous total cost is 153, and here total cost is 68. This has the less cost, and this is more reliable. That is why I'm saying northwest corner rule is not reliable, but as it is one of the method, and we are solving it. But in most of the cases, this Vogel's approximation is more reliable, and this is the way of calculation here. Northwest is more easier, but not so much reliable, and Vogel is, you have to do some more work. Instead of calculating in this way, you can do in this way, in a simple way. See, in a single table, you can do everything here. See, this is for the first iteration. This is for the first. No. This is first. Here it is also. This one is the first, and second like this, third, fourth like this. See here, firstly it is the maximum, then 6 is allocated here, and then again we calculate the difference here, and then it becomes largest here, and then assignment done here, and then again next calculated these things. See, this cross is there. Cross means, see, in while calculating, while assigning 6 here, this is removed, and that is why in further calculation these all will be cross. Cross means we cannot find the value. Value is because it is already removed, and it is also coming cross here because after removing this row. Likewise, others are also. And if you observe this carefully, whatever had done in different tables, that will come here as a combined result, and result is 68. And then you can remark like this: BAM method gives lesser cost than Northwest method and hence more appropriate. And in the exam, if you calculate in this way, and then your time consumption will be less. But previous one, displaying table again and again, time consumption will be more, and that is why I recommend this for your examination purpose. And you try with this method, and then you can try this, and some problems are here. You calculate it and submit as your third assignment. You submit this within this week. You submit this by Sunday. Can you submit?
Yes, sir.
Yeah. Submit it by Sunday. It will be your third assignment. And is there any doubt, any problem? Then tell me.
Sir,
Any problem, any difficulty?
sir, all the problems in the assignment we have to compare by both process. Doing both.
Both law. See, what is this? Question is solve the following transportation problem by Northwest Corner rule, Vogel approximation, and compare the result. Compare the result means which is more appropriate. That I have given you here as remark. This is the comparison. Lesser one is more appropriate because our target is minimum cost. Is it okay?
Okay, sir.
Then if there is no problem, then we can stop here. And next I'll take off assignment problem. I'll try to have this week. If there is problem, then I'll take next Monday. Okay, let us stop here.